right-click on driver.java. Scroll down to where it says Show In, and you should have an option for System Explorer or something like that. So I right-clicked on driver.java.
Well, that's the problem. I'm not getting that. I see everything.
So somebody who has a Windows one, there should be something roughly equivalent to this. Is there a Show In? Or maybe it's Open In instead of Show In? It's Show In? Is it at the top here like this? So same location? Yeah. You find it? Make sure you're right-clicking on driver.java over here on the left. That file.
Well, that's the problem. I don't see that file in my thing.
So you started off with this, and then you had a folder called source. You have that? And then you should have a folder called default package. And that's where your Java files should live.
Yeah. It's a scripting issue.
And maybe you didn't call. Well, no, hold on. You're probably looking inside of the JRE thing.
Yeah, that's.
Don't go in there. It's the folder underneath it. There's a source folder, SRC. So hide, hit the little arrow over here to compress that guy. So you should just have two folders here, JRE and another folder called source.
This is in projects, right? So when
Well,
I click on my class, it just shows me all the classes.
all right. You have over here on the left, you have a top level thing here like this, right? Under projects. Double click on that guy.
Yes.
You should have two folders in there. One called JRE, one called source. If you have any arrows over here on the left that are pointing down, click it so it points to the right. So everything's collapsed.
It didn't show my project.
Okay. Well, you must have messed up your project somehow. So,
I don't know. Yeah.
well, for right now, find your .java file wherever that was, wherever you put it, and just change the extension of it. So I'll go ahead and finish that. So if you go to source, you go to driver.java, and then you say show in System Explorer. This will show it to you outside of Eclipse on your computer. And then what I did is I just right-clicked on it and hit copy. Copy driver.java, where you can just hit Control-C, or on a Mac, Command-C. And then I went to any place else in your computer you could find, desktop, downloads, whatever. I pasted it, and that had been a file called driver.java here. And then I just clicked on it to allow me to rename the file, and I just changed it to driver.txt. Because the .java file is a text file. There's nothing special about the file, other than if you upload, Blackboard is partially written in Java. So if you upload a .java file to Blackboard, it doesn't treat it very nicely. So at the very least, rename the file to .txt, or copy your code and paste it into the comment, but make sure it maintains formatting so I don't get a Java program all on one line, which is going to increasingly become aggravating as the programs get more and more complex. Sooner rather than later, we're going to start using something called GitHub, where you'll be uploading your code once our code starts getting more complex to GitHub, and then you'll just give me a link to your code where I can view it online. Okay. Well, but GitHub has its own complications associated with it, so it's easy to use if you always follow my instructions. But when you don't follow my instructions and you start messing things up, you'll have broken GitHub repositories and all that stuff. So for right now, this is going to be your easier path, since you're always turning in a single file for a while. Yeah.
So from my end, it uploaded just fine. I opened it with a dot as a text file, and it looked fine, so I uploaded it. And it comes up like this for me. I just wanted to make sure it shows up like that.
We'll find out.
I guess
I'm going to give you a 0 if it doesn't.
I'll just
Yeah, we'll experiment some. I mean, and let me just give you some context on this a little bit. If I'm on my computer grading, I could pretty much work with any file format. I can download it and stuff like that. But I do a lot of my grading in the pool on my phone. There's a Blackboard instructor app for the phone. So, because when I go to the gym and go to the pool, I'm not swimming. I just stand in the therapy pool and kind of stretch lightly. And I do my grading in there. So I just hang out in the pool for an hour. So I need it to open up in my app. And it will not open a .java file. And if you're in my 470 class, which none of you are, it will not open a .rkt file. If you name it .txt, or if it's a Word document, opens those, great. So either of those two formats, it'll open right away for me, and I can grade it right there on my phone, and I'll be happy. It's probably going to earn your points, just from an enjoyment perspective, that I can grade everything on my phone. Because I typically don't need to run things through a compiler. I can read your code. I have the compilers built up here.
Would you use host if we just use GitHub right now?
I mean, if you know how to use it, I'm not gonna manage it. But if you know how to use GitHub, you can turn in a link for GitHub.
Okay.
But that means that you can't have an excuse of, oh, something went wrong with my GitHub repository.
Okay.
That's not going to fly until I start talking about GitHub. Right. Okay, so for today, we wrote like a modified FizzBuzz. I don't remember what the original FizzBuzz is. FizzBuzz. All the numbers between 1 and 1,000, right? So we're doing something a repetitive number of times. So I'm going to write a loop here for int I is equal to 1, I is less than or equal to 1,000, I is equal to I plus 1. All right, so there's my loop that takes I on a voyage between 1 and 1,000 inclusive. Everybody's cool with that? So we're starting to see all these crossovers from Python. Python, this would have been for I in range 1 to 1,000. Okay, and remember in Java is a strongly typed language, so when we define I, or define our counter, whatever our counter is going to be called, we have to give it a type. This is a type integer, so start I off at 1. Here's our Boolean expression. Change it by 1 each time. This is like our step in Python. Okay, so instead of it being built in with an automatic step by 1, we typically will say I equals I plus 1, but we could say I equals I plus 4. We could say I equals I minus 3, whatever we want to do. So that's the equivalent to our step. This is equivalent to the Boolean expression, which typically when we did the for loop in Python, we didn't actually have to put in there because we used the range function. All right, so I'm going to go through every value of I between 1 and 1,000, and I want to ask some questions related to that. So I'm going to print fizz if the number is evenly divisible by 3, only 3. I'm going to print buzz if it's evenly divisible by only 4. I'm going to print fizz buzz if the number is evenly divisible by both 3 and 4. And I guess based on this definition, you wouldn't print anything otherwise, but the fizz buzz says print the number otherwise. But as long as you did the logic for the other things. So we would leave things that aren't fizz or fizz buzz as just the number. Okay, so we're going to ask these questions. The first thing we're going to test is it equal to both? Is it evenly divisible by both? 3 and 4. So we're going to say if I mod 3 is equal to 0 and I mod 4 is equal to 0. If both of those things are true, we're going to do a system.out.println fizz buzz. All right. Now I'm going to go ahead and write this like I taught if-else statements so far, and then we'll clean it up. You may have written it a little bit cleaner than this, but I'm going to write it. So I'm going to say else if I mod 3 is equal to 0. System.out.println just fizz, else if I mod 4 is equal to 0, print out buzz else print out I. All right, I'm going to clean this up. This isn't the way I would write it. Logically, it is the way I would write it, but I'm going to clean this up quite a bit here in a second. Go ahead.
In theory, could you print just the part of the else, and then have a thing that causes the thing to print on a separate line, so that you have FizzBuzz together if it's
Oh, you mean if we find that it's equal to 3 and 4?
Yeah, I feel like if you just...
But you can ask 2 separate questions?
You could ask those 2 separate questions and avoid the top part.
Yeah, you could do that. What he wants to say is he wants to ask several individual questions. In fact, we'll write it your way here in a second. Let me clean this up first. I still think this would be the better way of writing it, but that's actually an interesting point you just brought up. All right, so this guy, if I go ahead and run this, this goes ahead and prints out your fizz and buzz and all that stuff for all those things. Now, if you remember from when I introduced if statements here, I talked about where's if statements in here? Ask questions. Okay. Yeah. So the official syntax for an if statement is if open parenthesis Boolean expression followed by a true statement, else false statement. That's optionally else false statement. Nothing says you have to have the curly braces. Typically, we're going to do more than one thing, so the curly braces are never wrong. The curly braces are a type of statement known as a block statement. So if you always have the curly braces, you're never wrong. Now, having said that, I could technically say else if, let me just steal this guy. So let me just clean this up. All right, so this is the same logic as we just had. So let me just run it real quick. You see it still works. All right, so here's my original if statement. If that's true, do this stuff. Else. This is the true statement of that else. It's another if statement. I chose not to use the curly braces. Okay, because if I say curly braces are never wrong, I could have said something like that and then put a closing curly brace later on somewhere. But technically, an if statement does not require the curly braces. It just requires a statement for when the Boolean expression is true, and another statement for when the Boolean expression is false if you choose to handle that case. If this is true, perform this statement. If it's false, perform this statement. If that is true, perform this statement. If it's false, perform this statement. If that is true, perform this statement. If it's false, perform this statement. Does that make sense? Now remember, in Python, you actually had a special keyword called elif, right? ELIF. Is that right? Yeah. So that was actually a single word. That's not what we're dealing with here. This is the keyword else, which then is expecting a statement following it. This is that statement. It's an if statement. Okay? So you just saw it a few minutes ago with the curly braces and all the indentation and things like that. And I told you it's never wrong to use curly braces. This would probably be an example when you have a whole bunch of else ifs where you'd want to omit the curly braces just because it gives you much cleaner looking code. But in general, notice here that even though I only have one statement here and this curly brace is not actually required, that's equivalent code. I went ahead and put the curly braces in there because it makes it look cleaner. Make sense? Go ahead.
Because the last else doesn't have if, it doesn't need parentheses. Is that right?
Yeah, I mean, it's just an else. It's otherwise do this because you'd only have parentheses if you wanted to ask another question, a Boolean expression. Notice every one of these parentheses has a Boolean expression in it. Boils down to true or false. Boils down to true or false. Make sense?
Yeah.
All right. So this would be one way you could write this. Now, let me show the way he suggested. So here, I'll show you multi-line comments here in Java. So if I want to comment out a big chunk of code like this, you just start it with a front slash asterisk and end it with an asterisk front slash. That's called a multi-line comment. It'll work in C, C++, Java, C#, Objective-C, pretty much any of our strongly typed languages that came from C. That's how you do a multi-line comment. Single line comment looks like this. Double front slash is a single line comment. But next line won't be in the comment. But if I come in here and I put stuff in there, they're all in the comment. Oh, and Eclipse puts a little asterisk there as part of its syntactic sugar to make you, really reinforce the idea that it's in a comment. And there is a shortcut in Eclipse somewhere for like highlighting a bunch of code and say, put this in a comment. I don't know what it is off the top of my head, but whatever. All right, so what he suggested is instead of asking this first if statement, what we actually can do is when we ask if it's evenly divided by 3, for example, instead of doing a println, we can just do a print. Then when we ask if it's evenly divisible by 4, but we won't do it in an else, we'll do it in another if. Then we'll put another print there. Else, let's see, we're going to have to do the catch-all because this would be the else of, yeah, this will work. And we'll just do a print like that. So, as we come through here, we're asking the question, if the value I'm currently looking at is evenly divisible by 3, go ahead and print to the screen fizz. But don't do a println. Don't press enter at the end of it. Just print it. So technically the cursor will be sitting right at the end of the Z, at the end of fizz. Then, notice this does not have an else in front of it. We're going to ask another question. If it's evenly divisible by 4, go ahead and print buzz. So that would actually put the buzz on the end of the fizz. Fizz buzz. Otherwise, if it didn't fire here and it didn't fire here, we will get to this else and we'll do a print I. And then what we'll go ahead and do is we'll say system.out.println. We can print the empty string. that'll actually kick it down to the final line. Print buzz. That should have kicked it down. The output did not look. So this is a fizz 999, so it printed out fizz. Oh, then it failed this one. Yeah, so this else actually doesn't solve the problem correctly. Because this else fires whenever it's not evenly divisible by 4, even if it previously was evenly divisible by 3. So I don't know that you can conveniently get the correct answer doing it this way. You'd have to make this else if not evenly divisible by 3 or 4. So now you still have to do the weird statement. Because this guy you want to happen only when neither of these things happen. Yeah, so this won't work as is unless you make this a much fancier looking else. So you would say else if I mod 3 not equal to 0 and I mod 4 not equal to 0. Then it would give you the right output. But realistically, this is harder to read and didn't save us anything from the other thing. So, but lesson from this is what he was trying to do is play around with formatting and saying we can do a print instead of a print lin, which will allow us to handle the fizz and the buzz portion of the mod 3 and the mod 4 in separate questions, allowing us to tack a buzz onto the end of a fizz if both of these things happen to fire. Now, I guess by the way I define the homework assignment, since I didn't actually say print out the number itself otherwise, then you could actually solve this problem like this. That would be an accurate way of solving the assignment as I gave it. Make sense? Mm-hmm. Got some holes in there where the numbers didn't fire, but this will give you the correct answer. My intended answer was this guy down here, but that is not what I had on the slide. What I had on the slide did not say to do anything with the numbers if it wasn't 3 or 4. So obviously I'll give you a 0 anyways, because I like to be a moving target. But as long as you showed me you practice with loops and you practice with questions and that stuff, and it's in spitting distance of the assignment I gave, we'll call it good. Heck, for traditional sake, I'll even say if you checked evenly division against other numbers than 3 and 4, I'll still do it. That's a Littman history story. I think I was in some algebra class, a couple days ago, right? And it was those word problems. And some word problem, it's like you have so many apples and you have so many, grapes or, whatever, something like that. And I had the right number, but gave my answer in terms of a different fruit. I switched to oranges or something like that. His teacher gave me a 0 because of it. So my dad goes in and was like arguing with him. I don't remember how old I was. I was like 8 or 9, something like that. I started math a little younger. When do you have algebra?
Freshman year.
8th grade? Freshman year?
What grade are you in when you're 8?
Well,
When you're
8.
Yeah.
5th grade.
Yeah.
Well, I guess like basic algebra, yeah.
'Cause I was taking classes over in the high school.
Yeah, then freshman for that level.
So you were taking freshman algebra when you were 8?
Yeah, it was weird. I was the weird
Yes, you
kid.
were, yeah.
I was
That was me.
when I was, I think 5 or 6, my mom just took me to the doctor and said, "What's wrong with him?" Like, I think that's a quote.
What's wrong?
Yeah, this was before it was cool to diagnose people with anything autism based. So, yeah, because now they just put everybody on the spectrum, right? Everybody's on drugs for being somewhere on the autism spectrum. But yeah, I was diagnosed with Asperger's when I was like, I think 6 or 7. I just think it makes me cool. And quirky. Plus, you always have an excuse. You do something weird, say the wrong thing. It's like, look, sorry, it's my Asperger's. I don't know what to tell you. All right, so I'll leave this up here as a comment so you have it. But my intended solution was in the ballpark of this guy down here.
Yeah.
Okay. Go ahead.
So for each of the mods, could you like put like kind of like a title like divisible by 3 with a quote like kind of for that and make it kind of so that way it's like organized?
Give me an example what you're trying to pull off.
So like for instance in the output if it's like divisible by 3 and then it has like the numbers like 369 with like with fizz.
Oh, so you don't want to? So could you write something other than fizz buzz? Like, could you say divisible by 3 and 4?
Yeah.
Something like that's fine.
Yeah. Okay.
Yeah, it's just these are just words.
Yeah.
You could have even put some stuff like that after it.
Okay.
That would, I mean, it's weird, but I'm weird. That's fine. That's cool. Yeah, I'm pretty good at reading code. So as long as you're writing stuff that's in the ballpark of what I'm trying to accomplish with the assignment, I won't take points off if you switch fruits on me. That guy. Although it is kind of funny, like, why did I switch fruits? If you're ever supposed to give the answer in the terms of apples, why? I mean, and it was handwritten. So, I mean, I chose to write oranges. So, it's like, look, I'm not.
Well, at least partial.
I hate apples.
No, you don't get to be my size and all that picky. I pretty much eat anything. If it might be food, I determine whether it's edible by putting it in my mouth. Okay, so questions about FizzBuzz?
I think
I'll go ahead and I'll just paste this into Slack for you as like something to remember me by. FizzBuzz code, something like that. All right. So let's start thinking about strings. I did mention that at some point I probably mentioned Java is a string-based language. So if you remember last semester, we worked with strings quite a bit in Python for manipulating strings and things like that. We're gonna redo some of those things we did for remember number conversion stuff. Yeah, we love those, right? So like converting from binary to decimal and decimal to binary and hex and all that stuff. We all remember how to do all the conversion stuff? It should be in your soul now. So like if we had the number 10111 and I wanted to convert binary to decimal, that is 1 0 1 1 1. This is in, let's see, 1 2 0 1 2 3 4. This is 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0th. So this is the 16th place, 8th place, 4's place, twos place, ones place. So this is 16 times 1 plus 8 times 0 plus 2 times 1 plus 1 times 1, which is 16, plus 2, which is 18, plus 1, which is 19. So this is the decimal version, decimal value 19, off of the binary number 10111. Got it? And if I want to go the other direction, I want to do 19 to binary. 19 decimal to binary. We take 19, we divide it by 2. 19 divided by 2 is 9. 9 times 2 is 18, with a remainder of 1. 9 divided by 2, 4. 4 times 2 is 8, with a remainder of 1. 4 divided by 2 is 0. 0 times 2 is, I'm sorry, not 0. 4 divided by 2 is 2. 2 times 2 is 4, with a remainder of 0. 2 divided by 2 is 1. 1 times 2 is 2, with a remainder of 0. 1 divided by 2 is 0. 2 goes into 1 0 times. 0 times 2 is 0, with a remainder of 1. Then we read our answer from bottom up, 10011. Isn't that a different number than we had before? 1s, 2s, 4s, 8s, 16s, 16s. Oh, hold on, I'm missing a number here. This is the 8th place. Oh, I missed my 4 here. Plus 4 times 1. So this is actually 23, right? I wrote everything right. I just omitted doing this math right here. 4 times 1. All right, so that's actually a 23, which means that just do this again real quick. 23 divided by 2 is 11. 11 times 2 is 22. Remainder of 1. 11 divided by 2 is 5. 5 times 2 is 10. Remainder of 1. 5 divided by 2 is 2. 2 times 2 is 4. Remainder 1. 2 divided by 2 is 1. 1 times 2 is 2. Remainder 0. 1 divided by 1 divided by 1 divided by 2 is 0. 0 times 2 is 0, with a remainder of 1. Then we read our answer from bottom up, 10111. All right, now they match. All right, that's our pattern. If we go from binary to decimal, we do it this way. Really, if we go from any base to decimal, we do it this way. If I'm doing base 2, I multiply it by 2 each time. This is the 1's place. Times 2 is the 2's place. Times 2 is the 4's place. Times 2 is the 8's place. Times 2 is the 16's place. If I was doing hexadecimal, this would be the 1's place. Times 16 is the 16's place. Times 16 is the 256 place. Times 16 is the 4096 place. Times 16 is the 65,535's place. 536 place. 536 place. Right?
You've done that before.
Well, at some point I probably did. Times 16 is the 2.1 billion's place.
Now I have to look it up. I don't even remember.
Well, it should be 4096 times 16 is 65,536, right? Times 16. Oh, it's only 1 billion. 1 million. Yeah, so my accuracy went way down on that. that next hop was rough. At least I'm not landing on the moon. So, all right, but you know what I'm saying? If we're doing base whatever, you multiply by that base as we move to the left. All right. Similarly, if I'm doing base whatever from decimal, I divide by that base, record the remainder each time. So if I'm doing base 8, octal, what are my possible remainders when I divide something by 8? Go ahead.
7 on down?
Yeah, 0 to 7. So I do base 2, my possible remainders were 0 or 1. Base 3, 0, 1, 2. Base 4, 0, 1, 2, 3. So it's always the base minus 0 to the base minus 1 are your possible remainders. Why isn't it 0 to the base? Can I have a remainder of 2 in binary?
No, because then it would just be remainder of 0.
Yes, that means I suck at math, right? Okay, so like I could say 4 divided by 2 is 1, remainder 2. 1 times 2 is 2, plus 2 is 4. It works, right? Okay, then somebody's going to look at it and say, no. Yeah, it doesn't fly. That's not how math works. All right, so if I had the base, that means it actually went in an extra time, and I need to go back and revisit division. All right, so if it's base 2, 0 to 1. Base 8, 0 to 7. Base 10, our number system, 0 to 9. What about base 16? 0 to 15 would be our initial stab at that based on our pattern, but what is it actually? For hexadecimal, base 16 is 0 to 9 and then A through F. Right? Remember we had to do those mappings?
Yep.
All right, so we're going to learn how to do that in Java. Well, actually, you're just going to learn how to do the pieces of that in Java.
I like color hex codes.
Yeah, same thing. Those are just hexadecimal numbers.
Right, I just didn't know that was the same thing. It's like that number was a color hex code. I didn't know if that was the same thing.
Yeah, so color hex codes are 6 values, right? Like FF, AA, 22, something like that. All right, so each of these is a 2 hextet number. So the largest value of this, of a hexadecimal, a 2 hextet decimal number is what? So FF, if I were to take FF and turn that guy into decimal, so from base 16 to decimal, F is actually 15, F is actually 15, this is the 16's place, this is the 1's place, so this is 16 times 15 plus 1 times 15. So I'll just copy this real quick. 255.
Okay.
So the range of values that a 2 hextet hexadecimal number can go between is 0 to 255. 0 to 255, 0 to 255,
Guess what color it was?
red,
Nope.
green. No, well,
Oh, okay.
listen to me. I'm explaining how this works here
Okay.
based on your question. Red, green, blue. This should be a heavy red color.
It's
This should be a heavy. This should be a red with a green.
It's orange.
Yeah, well, whatever. I'm just saying that
Right.
this is how those color codes work.
Right. That's cool.
Each 2 hextets. Just like we call binary, they're called bits. 0s and 1s are bits. In octal, it's octets. In decimal, it's digits. In hexadecimal, it's hextets. All right, so each of these is going to boil down to a number between 0 and 255. How red is it? How green is it? How blue is it?
So how did you know that like the 2 A's were green? Like, is that just?
Well, I know this is the green value,
Oh, okay. Just a minute.
and AA is higher than 0,
Yeah.
so there's quite a bit of green in there. This is kind of like a 2/3 green, something like that. This is a hard red, is what that guy is. That's as red as it gets over there. So AA would be 160 plus 10. What's up? It's 170, right? So this is 170 on the green.
I think it moves up. Oh yeah, because it would it'd just be whatever heavy color it is. You can change it.
Make sense? How those work?
Yeah.
Okay, so those are your color code things. Using just normal crap we've been doing in class since last semester. Isn't it funny how we're applying all these basic things to things that happen all the time, but it just looks scary when you have the color codes, right?
Yeah, no, it's like F03.
Yeah, you just convert it yourself. You just decide what your red, green, blue is, convert it from decimal into hex, and now you got your color code. All right. In fact, we can even write a program that does that. It's a good idea for a program that does that.
That's a really good idea.
Yeah, it is. So, having said that, let's look at scanner real quick.
We already know who that is.
So, read crap in from the user. That's what scanner's used for. All right. So, scanner, the constructor for scanner requires us to, tell it where we will be reading from. Actually, that's a dangling preposition. From where we will be reading. But we're going to leave it. Go ahead.
Please tell me that if you ever have this from the quiz, read crap into the user.
Word for word. It's got to be word for word.
Okay.
Well, this is like kind of almost the overcorrection, because with technology, and I mentioned this last semester, I mentioned this in all my classes, so often people try to use these big fancy sounding words that mean something easy. Right? I want to ask the user for some stuff. Ask him for some stuff and read it in. Well, we're going to use a bit stream, and we're going to... No, you're not. You're going to use a scanner to read crap in. That's what you're going to do. How it works under the hood is important, and you're going to learn that in here. But anything that we can reduce the complication on, the better. All right? So when we build a scanner, so we're going to build a variable of type scanner. So scanners are object types. How do we know this guy is likely an object type? Starts with a capital letter. So typically naming conventions in Java or any object-oriented language. Naming conventions, let's put this on its own slide instead of hiding it in a bullet point. Naming conventions. If it starts with a capital letter, it is likely a class name. If it starts with a lower case letter and parentheses are present, it is likely a method or a function name. If it starts with a lowercase letter and parentheses are not present, it is likely a variable name. And I say likely by all these because you can name classes all lowercase, you can name variables all uppercase. This tends to be a naming convention in modern programming. Typically, the languages have built-in classes that follow all these rules, and then we hope that modern programmers also sort of kind of follow these rules, but do what you want. Just makes your code a little bit easier to read. Otherwise, you might have to go digging a little bit to just find out what something is. You could pretty quickly test it with a compiler. You know, try to create an instance of the class, and if you have something that's in uppercase, try to create an instance of that class, run it through the compiler. If it screams at you, probably wasn't a class. All right, so whoever wrote that was, it's just kind of, it's the advantage of software. If we had that in hardware, you're running electricity through it, and bad things can happen. All right, so scanner, when we build one of these guys, now this is a good example from an object-oriented programming perspective, right? Object-oriented programming attempts to solve problems in the way that we already solve them as human beings, right? We way back when, last semester, we talked about the object-oriented versus the procedural telephone, pile of wires versus the thing that actually looks like a phone. Okay, this is an object, and when we see something like this, we know that this object has some capabilities, right? And we think about what are the things we can do with this thing, and this is so if I need to text somebody, the tool I go and grab, the object I grab is my phone. If I want to call somebody, I grab a phone. If I want to do a Google search, I grab a phone. If I want to listen to music, I grab a phone. This thing does too much, is what it comes down to, right? Okay, but we have objects that do things. If I want to read input from the user, I need a scanner. I need to grab a scanner. Now, in programming languages, the scanner is kept inside the documentation, and we're going to first need to get a scanner. We're going to need to build a scanner. So we can either run to Home Depot and buy one, or we can just instantiate one in our code real quick. Okay, go to videotape yourself going to Home Depot and asking them for a Java scanner. You get extra credit. You got to videotape the whole thing. Just refuse and look, your website said you have it. It's in aisle 4.
Oh, I hated when people, whenever they came in Target.
All right.
Online only on the site.
So, documentation for the scanner, if I do Java scanner, it's going to ask me for an input stream as a parameter. So, let's see, just do Java scanner class. So here's the actual documentation for scanner. I'm not going to talk too much about documentation right now because I'm going to spend a lot more time talking about this later. But we have a whole bunch of different ways of constructing scanners. This is built into the language. And one of them is this thing called an input stream. Okay? Now, we also have a class called system. Go ahead.
Once you initialize scanner for the first time, do you have to keep doing that, or can you just assign the same scanner to a new variable?
Well, you wouldn't even need to assign it to a new variable. Once you have a scanner, you can use that scanner over and over again for the duration of your program.
Okay.
Yeah. All right, so this scanner is asking me to pass him something called an input stream. And now there's a class called system. We've already been exposed to system, right? System.out.println. All right, so system.out is an output stream. This happens to be the output stream associated with the monitor. There's another file called another field called system.in, which is an input stream that's associated with the keyboard. All right, so if I want to read stuff in from the keyboard, I build my scanner with something called system.in. So I'm going to go ahead and dump all this. Now, one thing we'll notice here if I go back to scanner is scanner actually lives inside of a library called java.util. So it's not part of the core java.lang, I think it's java.base.lang language. So it's not given to us by default. Eclipse, you'll see when I try to create a scanner, if I say scanner input is equal to new scanner system.in, it's going to yell at me here, and if I hover over scanner, the option it gives me is to import scanner from java.util. So at the very top, I get an import statement that says, give me access to the class called scanner from java.util. So this is a very specific way of getting scanner. You could also say import java.util.star, which will make your compiled file a lot larger because you're saying, look, just give me access to everything inside that util toolbox. But this is saying, just give me access to scanner. So this gives you access to the blueprint for building a scanner, which lives in java.util. This is me creating a variable named input of type scanner, and this guy is going to be equal to a new scanner, giving it the input stream I want to read from. What's the output of that program going to be? What do you suspect?
Yeah, whatever the user types in, it'll spit it back out.
Read the code and try again. I know what scanners are supposed to do. I haven't really used this tool yet. I've built a scanner. I said, print my scanner.
Well, yeah.
What does a scanner look like when I print it to the screen? What's it going to look like?
Wait. Isn't it just nothing?
What's everything look like in computer code?
Oh, numbers.
Memory addressy looking thing. Okay. There's our memory addressy looking thing. Actually, this is actually not a normal memory addressy looking thing because they've overridden the toString method, which we'll talk about later. But just this is a bunch of gibberishy stuff. For right now, let's call it a memory addressy looking thing. Okay. Whenever you see this new keyword here, new, our real estate agent goes and gets enough memory to build an object. Just say enough memory from the OS to build an object. In this case, he's actually asking the Java virtual machine for some memory. So whenever you see the new keyword present, you know that you're actually asking for some memory. So right here, this is a normal plain Jane variable, right? This is the type. This is the name of the variable. This is no different than me saying int I is equal to 6. Type is int, type is scanner. Variable name is I, variable name is input. We're assigning it a value. This guy, we're assigning the value of 6. This guy down here, we're assigning the value that is returned from that code right there. And the new keyword is involved, so what we're actually assigning input is a memory address where it can find the built scanner. Okay, this is the scanner's constructor. The constructor takes in an input stream that we want to build the scanner in terms of. This is going to return where that guy was actually built inside of our computer's memory. Okay. So I can print out, give me a value, something like that. And we'll do a print lin on it. That way it kind of shows up as a prompt. And then we'll go ahead and we'll say, here, let's say, give me an int value. And we'll say int val is equal to input, which is the name of my scanner. So let's go back to the documentation for scanner. And we have several different functions for getting values. So we have next int, I think is one of them. I think there's a read line. Read line might be the one that is used most often. Okay, so we have something called next. Next byte. Here we got something called next int. Scans the next token of the input as an int. So I'm going to say input dot next int, and that's going to read that value into val, and then we'll go ahead and say system.out.println whatever val read in. So it's going to ask us for something, it's going to read it in, then we're going to spit it back out proving that we read it in. So give me a value, we'll give it a 5, press enter, and there's our 5. Make sense?
Got it, yeah.
All right. If I wanted to read in a string instead of next int, I forgot that we don't have the command completion on here working for some reason. We have something called next line that will give me a string. So I can say input dot next line, and notice here that it's yelling at me because I'm trying to store this guy into an int, but next line returns a string, so it's not going to be happy about this. So I can store this into a string called val if I want to. I need it stored in the right type. Python didn't care. Python said, hey, it's a loosely typed language. Create a variable named val, put whatever you want in it. Java says strongly typed language. You need to tell me what kind of value this variable val is built to hold, and you better put something that's compatible with it in there. All right. So now I can still type in a 5 and press enter, but it read that 5 in as the string 5. And we can prove that by saying, oh, well, let's just go ahead and concatenate a 7 onto that. So if it was a int, 5 plus 7 would give me a 12. But if it's a string, 5 plus 7 would give me a 57. Right? It'll glue them together. So there's my 57. As opposed to int, next int, there's my 12. Make sense? Good.
Is there like a generic thing you can use instead of like next int or next line?
When I use it, I almost always use next line and get a string. And because, again, Java is a string-based language, if you can get something as a string, you could turn it into anything you want. So for example, let's say, I'll just go back to the string version of this. So I'll use next line. But let's say that I want this to not be 57. I want it to actually do the math. Okay, so I can say int val as int is equal to integer.parseInt of val. Now I get an actual number out of it. So I'll go ahead and read val in as a string. I got a string. Now what I'm telling you as a Java developer, strings are king. If I have something as a string, I can do anything I want with it. Okay? So right here I have another little tool. And I'm not going to talk about these tools too much, but for right now, because there's a whole lesson on why I call this tool this way and why I call the next line method this way. That's a lesson we're going to talk about. We're just not talking about it right now. So for right now, this is how I use this tool. So we have this tool called integer. We talked about it a little bit last class. I think I said the first 2 classes we're going to introduce are what? A string and character, I think I said. Does that sound right? Am I lying? I think I said that. All right. And one of the reasons is I said that there are classes for all of the primitive types. What are the primitive types? What does it mean for something to be a primitive type in Java? It can only hold a value. That's the extent of its capabilities. We talked about that, right? Recently? So if I want to do extra things to those primitive types, I need to have classes that can operate on them. All right, because an object type can hold 0 or more values and also potentially do more. Primitive types can only hold a value. So if I have a character, or I have an int, I have a char, or I have an int, one of our primitive types, and I want to do something to it, I want to operate on those guys, I need a class that allows me to do extra stuff to them. Okay, so I went over to Home Depot and I got the integer. I think of it like almost like a juicer, right? So this is this integer class, and he knows how to do a bunch of things to ints or related to ints. And one of the things he knows to do, the reason I call this guy a juicer, is we have this thing called parseInt. And what parseInt does is it allows me to, so think of it like a running blender, okay? You drop a string representation of an int into it, and it fires out the int equivalent. Builds it for you. All right? So I read in the string 5. I dropped the string 5 into here. It shot out the int 5. That's what integer.parseInt does.
Why would you need to keep it as a string? Then why would you just like go back to what you had before?
Well, he asked the question of if you wanted to have a generic read stuff, and realistically, just let's call it out of laziness, I would almost always use next line. The strings are so malleable. I'll bring it in as a string, and I'll just do what I want with it. If I want it as an int, I'll convert it real quick. If I just know I'm always dealing with ints, that's fine. But let's say you're reading in 10 pieces of information from the user. And some of them are ints, and some of them are chars, and some of them are strings. I'd probably just bring them all in as a string and then just convert them to what I needed them to be. So use the right tool for the job. This isn't any different than you have to fix something around the house. You look in the drawer, you find out what you have, and you solve the problem with it. Strings are really easy to work with in Java, so if I can just remember this one guy and just bring a string in, I can turn it into anything I want. But if you bring a lot of ints in, might as well use next int and not have to do a whole bunch of parsing. All right, that makes sense? All right. For the next little bit, though, we're not allowed to use parseInt. I'll tell you when you're allowed to use it again. Because there's actually a second version of parseInt that would actually make life pretty easy if we're doing number conversion stuff. But we're not going to learn that yet. But you're not even allowed to use the simple version. If you want to write your own version of this, you can. But your own version of it shouldn't be difficult. Well, it's not. In fact, that sounds like a great homework assignment. I agree.
It's not a great homework assignment.
What are you talking about?
No, it does not. That one does not solve problems.
Really?
No, not to anyone else. No.
Really? So let's just connect some dots here for you. So let's say I have the string 132, and I want to convert this from decimal to decimal. 1, 3, 2. This is the 10 to the 3's place. This is the 10 to the 2's. I'm sorry, 10 to the 2's place. 10 to the 1's place. 10 to the 0's place. This is 100 place. This is the 10's place. This is the 1's place. 1 times 10 is 10, times 10 is 100. So this is 100 times 1 plus 10 times 3 plus 1 times 2, which is 132. Is that any different than converting binary to decimal or hexadecimal to decimal? Exact same thing. String representation of an int. In decimal format, what did I do? Converted it to a int by following the same pattern as we did for any of these other things. That's what parseInt does. Make sense? All right, so let me give you enough new stuff to work with so that your next couple of days can be hell.
Thanks.
I like how you're.
All right, so we're going to talk about strings here for a few minutes. All right, so strings have a length method. They have a char@, method. I'm just going to show you those two for right now. Didn't we already look at these?
Similar.
So if I say string s is equal to hello, and oh, here, you probably want to keep your scanner here. We'll keep that code in there. So I'll say string s is equal to hello. If I say system.out.println s.length, so I have two variables here, type string, named s, equal to this guy. Name string, or type string, named s2, equal to this guy. I'll go ahead and print out the length of each of these. So this guy will print out a 5, this guy will print out an 8, because s2 has 8 characters in it, s has 5 characters in it. Make sense?
Does Java look at that as an integer or char?
This is an int.
Okay.
Yeah. So this guy fires out an int type. Go ahead.
Could you go back to your, okay, so to the, highlight the O, not go up highlight, but go up to the O line, is that the O?
The which? Up here?
Yeah, Java scanner. They just go up.
Oh, this?
And then they, not, click on the air, the left, like the little clickable on the left.
Which line do you want me to click on?
Line 1, there's a clickable on the left.
Oh, this guy?
Yeah, what does that say?
I can remove it, some of that. It's just an Eclipse thing.
Oh, it says on mine, it says like, remove unused import.
That's because right now I'm not using it because it's commented out.
Oh.
That's why it has a little yellow squiggly underneath it, is because I'm not technically using scanner right this second.
So if you're not using the method at all, it's just,
I would still just leave it up here, don't worry about it.
yeah. But I'm just saying that that's what the error's happening now.
It's not an error.
Or not,
Yeah, it's just a warning or an FYI, something like that. Errors would be in red squigglies. All right, so that gives me those two guys. If I say system.out.println s.char@3, strings are 0 indexed, so this is bucket 0, bucket 1, bucket 2, bucket 3. So that's the second L that will print out here. s.char@3 will give me an L. s2.char@3, this is 0, 1, 2, 3, will give me a P. So there's s2.char@3. There's the P. All right, so char@ allows me to get at individual characters that live inside of my string. So this guy boils down to a char. Okay. So if I have a number 10111, so if I want to take whatever is in S, 10111, and I want to turn it into its integer equivalent in decimal, we know how to do this, right? This is the 1's place, 2's place, 4's place, 8's place, 16's place. So this is 16 plus 4, plus 2, plus 1. So that's 23.
Yes.
So you should have a code based on this example that would output 23. So you need to loop through this entire string one way or another. This is a problem you solved last semester, right? All right, but now you're doing it in Java using the tools that you have available to you. Okay, so you're not allowed to use integer.parseInt. It would barely help you on this question anyways. All right, so you can use loops, you can ask questions, you can use variables. I think that's all you'll need. Questions about what I'm asking you to do?
Okay, so what do you?
If you wanted to take this one little step further and connect the dots, you could read in the number that you want them to enter as a binary number. So instead of just hard coding it in here, now your code should work for other binary numbers. So I should be able to say 1, 0, should work for that too. You should write generic code that will operate on whatever is currently in S. But if you want to use scanner to read in your value for S, instead of testing by changing the value in here, you can do that as well. That makes sense? Do you have a question?
Could you use other stuff in Slack, please?
Nope.
Nope.
Yeah, I'll put this in Slack. All right, should be easy enough.
So you just want us to go through each of those numbers?
I want you to convert this binary. I want you to convert this binary number represented as a string into its decimal equivalent represented as an int.
Oh.
Make sense? So this will always be a string containing only zeros and ones. I want you to spit out in this example, well, I don't know what that number is, but the int equivalent to it, where if I did +1, it will add 1 to it in terms of one number larger. All right, today, first day of student, faculty, staff Bible study, God and Grub. Go to the cafeteria, sign into the Bible study. You get your lunch, take it down to the terrace room, and the actual thing is from like 12:15 to 1, so I actually usually go to lunch right after class if you want to sit in the caf and then eat, and then we can just all go down and we get a big computer science table, and then we get tattoos. This is not not the front row tattoo. This is the one that doesn't require the dipping. All right, so everybody clear on the assignment? I'll put this up on Slack. All right, see everybody on Thursday.